Welcome students to the introduction class of quantum mechanics. So before we go to the quantum mechanics, we must learn what is the difference between classical and quantum mechanics. In your school level, you have a little bit flavor of modern physics, where you have studied de concept of de Broglie wavelength, which is, we know, lambda equals to h by mv. The answer of that question, what is the difference between classical and quantum mechanics, lies here. Say for example, we are considering a cricket ball of mass say 50 gram, and the ball is moving at a velocity say 30 meter per second. Now if I want to find the associated wavelength of the cricket ball, you will find it will come of the order 10 to the power minus 33 meter or so. Whereas if I want to find the wavelength of an electron having the mass 9.1 10 to the power minus 31 kg, moving at a velocity 10 to the power 7 meter per second. Now why I am taking this value as the velocity of electron? This is the average value of the velocity of an electron. Now if I find this particular wavelength for an electron, you will find it will come of the order minus 10 to the power 10 meter. Now you just see, we play with the cricket ball. It has a certain radius which is around 3.5 to 4 centimeter. We can measure that radius in our naked eye, and the associated wavelength is coming 10 to the power minus 33 meter. That means after the decimal point there will be 33 number of zeros, then a value will be coming, which is basically practically negligible. So what we see, the associated wavelength to the ball is practically zero. Whereas if I go to the electron, what is the size of an electron? Is diameter or radius or circumference? It is of the order 10 to the power minus 15 meter, which is Fermi. Right? Now which one is greater? 10 to the power minus 15 or 10 to the power minus 10? Obviously 10 to the power minus 10 is greater. Now you see, for an electron we can see that the associated wavelength is coming greater than the size of the particle. Here is the answer. So if the wavelength is greater than the size of the particle, or it may happen the size and the wavelength are comparable, they may be same order, then also we can say the particle will follow quantum mechanics. Is it clear? Now another important difference lies, which is relativistic mass equation. You know this particular equation. So if a particle is moving at velocity v, the mass will change like this, where m0 is the rest mass of the particle and c is the velocity of light. Now if I find the mass of a car, okay, say we are considering the rest mass is m0 for both a car and for an electron. Now if the velocity of a car is 60 km per hour, you will find the mass will be coming approximately equals to m0. That is why in classical mechanics problem, whatever mass has been given in our problem, we have taken that particular mass. We have not seen whether the body is at rest or at motion, because they are same. Now if I do the same calculation for an electron having the velocity 10 to the power 7 meter per second, we will find this mass will be coming greater than the rest mass of the electron. So what I can see, if the particle is moving at a speed comparable to the velocity of light, the mass of the particle will increase compared to its rest mass. So these are two main difference between classical and quantum mechanics. Then you can say classical mechanics is basically macroscopic, quantum mechanics is microscopic. In classical mechanics, Newton's law of motion will be followed. In quantum mechanics, Newton's laws of motion will not be followed properly. So I hope you have understood the difference between classical and quantum mechanics.